So this video is going to talk about changing your variables. Sometimes they'll specify what U substitution they want to use. Sometimes the answers won't be the numerical values of the definite integrals. That's going to be what the new setup would be. So this flows very easily after definite integrals. They're only 4 examples, so how hard could it be? But just focus on what variable is being used. So it's important to note that this integral is completely in terms of x. It has a dx at the end, and this 0 and this 1 are x values. It is asking me specifically to do u sub, to where I let u become the x squared plus 1. Okay, well that's not unheard of. We can do that. So if that's my u, then my du is going to be 2x dx. I have the x and the dx. I need the 2, so I'm going to balance it with a 1/2. So I'm going to have 1/2 integral, and I'm not going to write the 0 and the 1, and you'll see why in just a second. From 0 to 1 of u to the third du. So sometimes for multiple choice, what you're going to see is 4 different setups that look just like this. So they just want to see that you can figure out who your du is and what you need to adjust and and what it's going to look like in terms, taking it out of x's and putting it in terms of u. The problem is I cannot keep these as my upper and lower bounds, because remember, those were x's, because that's when the problem was in terms of x. Well, currently my problem is in terms of u. But I have this relationship right here that can turn x's into u's. If I know that u is x squared plus 1, and I know he's an x, and I want him to be a u, so u equals 1 squared plus 1, so that x that's a 1 becomes a 2 as a u. And then I'm going to do it again for this 0. I'm plugging the 0 in for x because that's what he is, and I get a 1 back out. So this 0 that's an x becomes a 1 that's a u. So let's stop right here for just a second. Sometimes you're going to see multiple choice that's just these setups. So notice it was in terms of x's, now it's in terms of u's. My upper and lower bounds were in terms of x's, and now they're in terms of u's. So they could stop right there. But what we can do is go ahead and integrate it. So I'm here. Well, this is where most of the time we'll substitute our u back in. But guys, think about what that would mean. If I put this back in here, I'm now back in terms of x's. Well, remember the 2 and the 1 are u's. So since you've gone ahead and converted your upper and lower bounds to u's, you can evaluate this right here without ever substituting your x squared plus 1 back in. So this is going to be 1/8, then 2 to the 4th, which is 16, minus 1 to the 4th, which is 1. So that's 15/8. And that's your answer. That's it. So the point of this is I took my original problem, the yellow, and I put it in terms of u. But the kicker is you have to change your upper and lower bounds from 0 to 1 to 1 to 2, because the 0 to 1 was in terms of x's and the 1 to 2 is in terms of u. Once you change those upper and lower bounds, you don't ever go back to x's because it's all in terms of u now. Okay, now I want to redo this problem, and I want to do it the way you would have done it before I taught you this. So you would have let u be x squared plus 1. Your du would be 2x dx. You would need a 2, balance it with a 1/2. And then you would integrate. And then you would substitute your u back in. And again, remember, these are x's. We never translated them into u's. So they can't go in here. They have to go in here. So then I have 1/8. All right, 1 squared is 1. Plus 1 is 2. And that would be a 1. And that doesn't work. Okay, I see why it doesn't work. I lost this 4. So when I plug my u, my x squared plus 1 in, it still has to be raised to the 4th power. I just lost my 4. I was wondering why it didn't work. Okay, so let's try this part again. So I've got 1/8. Okay, now I'm going to plug the 1 in. So 1 squared is 1, plus 1 is 2. And then I've got 2 to the 4th, which is 16. Minus. Now I'm going to plug in the 0. 0 squared is 0, plus 1 is 1. 1 to the 4th power is 1. And that gives me 15/8. So you get the same answer either way. So everything in black and the end that's blue is what you've done. But look at how much more work it took. So what this section is going to challenge you on is, once you do your u sub, take your lower and your upper, translate them from x's to u's, and then when you integrate, you don't ever have to put what u is back in for u, because you've adjusted your bounds to be u's. Okay, that's a lot. Let's try another one. Okay, so this one's multiple choice. So this one's not asking what the numerical answer is. This is the one that's asking for the setup. So it's telling me my u sub. Okay, so here's my problem. So I have 2 trig functions, so it makes sense to let the u be the one with the extra stuff on it. So if that's my u, I need to find my du. Derivative of sine, this is a turduck, so cosine of 2x times the 2. So 2 cosine 2x dx. Okay, I have the cosine of 2x. I need the 2, so it needs to be balanced with a 1/2. And I'm going to have u to the 5th du. But, and every single one of these has a u to the 5th. He has a -2, and he is a 2, so I can take those 2 out. And then if you'll see, the only difference between b, c, and d are the lower and the upper bounds. So I'm going to take my x's, which are pi over 2 and pi over 6. These are x's. I know they're x's because they're the lower and the upper bounds for an integral that has x's. That's in terms of x. I'm going to use this equation to translate those x's into u's. So u equals sine of 2 times pi over 2 would just be pi. Sine of pi is over here, and then sine of pi is 0. So that pi over 2 turns into a 0. Now I'm going to do pi over 6. U equals sine of 2 times pi over 6, which is pi over 3. Pi over 3 is the tall one, and that's root 3 over 2. There he is. So if you look back at number 1, you may be thinking, well, if I can do it the old way, I want to do it the old way. I'm comfortable with the old way. Well, that's fine. But this isn't a way where they can take a multiple choice example and force you to not only do the U sub, which you have to do, but to change your variables from X's to U's permanently. And if I was going to integrate this, then I never go back to X's. And then I would just clean it up from there. But you don't ever plug your X's back in because you have changed over to U's. Okay, let's look at number 3. All right, it's very nice. It tells me, but I think I would have known to let my U be the power. So if that's my U, okay, so this piece right here is him. So we need the 1/2, so I'm going to balance it with a 2. And that would give me e to the u du. So I don't like him, and I don't like him. So now I just got to figure out which lower and upper bounds. Okay, so the 1 and the 4 that you see here are x's. I'm going to turn them into u's by using this equation. So u equals 4 to the 1/2. That's a 2. And u equals 1 to the 1/2. That's a 1. So I want to go from 1 to 2. C. Okay, number 4. It says if f is continuous and from 0 to 8 of f of u du is 6, what is the value from 1 to 3 of x f of x squared minus 1 dx? Okay. So looks like my u is going to be x squared minus 1. So my du is going to be 2x dx. I see the x needs a 2, so I'm going to balance it with a 1/2. And that's now going to give me f of u du, which is what I want. I need to change. No, it already told it. It already told me that a 0 and an 8. And even if they hadn't, I could plug a 3 in here. 3 squared is 9, minus 1 is 8. And then 1 squared is 1, minus 1 is 0. So I already know it's going to go from 8 to 0. They didn't have to tell me that. I could have figured that out. Knowing that x was 1 and 3, and knowing my formula, I could have found my u, lower and upper. Okay, now this has to come into play. It tells me that the integral from 0 to 8 of f of u du is a 6. Well, that's this. This is a 6. Well, what did we have to add to it? We had to multiply it by 1/2. So the answer of this is a 3, because we had to balance it with a 1/2. The homework on this section is super short. Take your time. This is not difficult, but it is an upper level thinking concept. But I think once you get the hang of it, it's really easy.